In this video, we'll go over the homework that follows the lecture 18.1 that is dedicated to separable differential equations. And as always, I hope that you watched this video lecture, and let's go ahead and jump right into the homework. And the first question is, we are given a differential equation, and we need to solve it. And in this particular case, we don't have to solve it actually, we just have to set it up. So the first thing we notice is that this equation is separable. Separable means it can be written in the form y prime is equal to the product of two functions. One of them is a function of y and the other one is a function of x. And to solve it, here's what we do. We divide both sides by let me rewrite that. We separate the variables. So on the left side we write g of y, and on the right side, on the left side after we divide both sides by g of y, on the left side we have the reciprocal of g of y, on the right side we have f of x, and what we do next, it looks like we're multiplying by dx, but it's not actually multiplication. But if you write the derivative on the left hand side in the Leibniz notation, then bringing dy to the right side does look like we multiplied both sides by dy. But again, these expressions are called differentials, so it's not quite multiplication. But after we apply the integral to both sides, then it makes more sense. So this is how we solve separable differential equations. So in our case, we're going to divide both sides by 1 minus 4y. So 8x squared plus 3 remains on the right side. However, the y prime, we're going to split into dy, which will remain on the left side, and dx, which will go to the right side. And now we proceed with setting the integrals, or rather applying the integrals to both sides of this equation. So now we are ready to provide the answer to this particular question, which wasn't to solve the equation but to just set it up. And good job. Let's take a look at the other problem. And once again, we have a separable differential equation. How do we know it's separable? Because we can rewrite it as a product of function of x and function of y. So here we have 1 over sine of 5y multiplied by 16 cotangent 4x times cosecant 4x dx. And once we acknowledge that this is separable, so this is your function of y, sorry, there's no dx there, and this is your function of x, now we can separate the variables. So we multiply both sides by sine of 5y. So on the left side we have sine of 5y, and on the right side we have 16 cotangent 4x times cosecant (4x), and we separate the variables, so we write dy on the left, we keep dy on the left, write dx on the right, and we apply the integral to both sides. And the next step is to integrate. So this is where we get to use our knowledge of integral calculus. So on the left side we have -1/5 of cosine of 5y So this is just a linear substitution such as t equals 5y. And on the right side, I believe we're going to end up with, what do we have? It's going to be negative 16 over 4 cosecant of 4x. And at some point we have to put plus c either on the left or on the right. So let's just stick it here on the right side. And yeah, let's just make sure that derivative of cosecant is negative cotangent cosecant, which I think the case. So, and by the chain rule, those force cancel. So next we need to isolate 5y, or rather y, but we're going to do it in steps. So first we're going to multiply everything by negative 5. So, and since we probably will be changing constants, let's label this constant as c. Well, let's just use index 1 here. So multiply both sides by negative 5. So we have cosine of 5y equals 16 over 4 is negative 4. Multiplying it by negative 5, so we get 20. So it's 20 cosecant of 4x minus 5c1, which we can, this whole negative 5 of c1, we can relabel as plus some other constant, let's call it c2. Now, assuming that this is between 1 and negative 1, we're going to apply arc cosine function to both sides, and that's also only going to be true if 5y is between 0 and pi. So I think we have to make that constraint, and under these conditions 5y will be equal to arc cosine of 20 times cosecant 4x plus c2, and the last step we're going to perform, let me shuffle things around a little here. So the last thing we're going to do is we're going to divide everything by 5. So y is equal to 1/5 arc cosine of 20 cosecant of 4x plus some constant c2. And since we're not going to have any other constants, we can label this last constant as c. And that's the answer I will be entering. So we have 1/5 arc cosine of 20 cosecant 4x plus c, and that should do it. Here's the next problem. It's a separable equation. How do we know? Because it can be written as a product of function of x and function of y. Now, to separate the variables, we multiply both sides by 2y minus 3. So negative 2x minus 4 stays on the right side. Now dy stays on the left, dx goes to the right, and we proceed with applying integral to both sides, and integrating this gives us y squared minus 3y on the left, and minus x squared minus 4x plus c on the right. And in this case, we don't have to write the solution in explicit form, so we're pretty much done. Let's just type this up. And that's it for number 3. Number 4. It's a separable equation, so we're going to separate it by dividing both sides So here we need to be careful, I think, because the question here is doesn't ask us to solve the equation, because if you start solving it, you're gonna quickly realize that the integral on the left side just cannot be found easily, right? So we would kind of get stuck over here. But let's read the question carefully and let's try to understand what it's asking. It says, find any values of y corresponding to constant solutions for the differential equation. Now, to have a constant solution, what does that mean? So constant solution means y is equal to some constant. But if y is equal to some constant, what's derivative of y then equal to? Well, derivative of a constant is 0. So what this problem is asking us, it's actually asking us to set this whole thing equal to 0 and find the y values that make this a true statement. Now, by the zero product property, we conclude that either ln of 5y equals to 0 or cosine of 5x equals to 0. But the question is not about x, the question is about for which y values, so we're going to focus on the left-hand side. So ln of 5y is equal to 0 only if 5y is equal to 1, which is only the case if y is equal to 1/5. So here I'm just going to type 1/5. So just make sure you read the problem carefully and make a full sense out of the question. Here we have to solve it, so let's go ahead and solve it. We're going to separate it. And we're going to apply the integration to both sides. And on the left side, we have ln of absolute value of y minus 3. On the right side, we have 4x squared minus 5x plus some constant. Let's call it c1. Next, we're going to exponentiate both sides like this. So on the left side, we have absolute value of y minus 3. On the right side, we have e to the power 4x squared minus 5x plus c1. But instead of writing it as plus c1 in the exponent, we can actually write it as times e to the power c1. And that whole thing can now become c2. Now, we are going to handle the absolute value. So y minus 3 equals, in absolute value, equals to something, means that y minus 3 will be equal to plus minus that something and that plus minus can be absorbed by the constant, so let's just call it C3. And the last thing we have is we just need to add 3 to isolate the y value, and here's what we get. And since this is the last constant, we can just call it C. And this will be the final answer in explicit form. If we didn't have to write it in explicit form, then we would have been done 3 steps ago. So here it is important to understand that we are asked to provide the answer in explicit form. That's why we're doing this. Here's another equation. Again, it's separable, so we separate it. We bring y to the 4 on the left, and I guess it makes sense to write it in exponential form. So y to the power negative 4 dy 10 ln x dx. Apply the integral. On the left side we have y to the negative 3 over negative 3. On the right side we have 10 times integral of ln x. To do this integral, you may have to do it on a side, on a scratch paper somewhere. So integral of ln x dx, I think it's a well-known integral by now. We're going to do it by parts. So u is ln x, dv is dx, du is 1 over x dx, and v is x. I think at some point I would probably benefit from remembering this integral, but anyway, by parts. So we have x ln x minus integral v du, which is 1, so it's just minus x plus c. So we definitely want to either be able to do this integral real quick or just remember it. But I'm going to refer to this piece of knowledge here. And on the right side we have 10 times x ln x minus x plus c. And to isolate y, we multiply both sides by negative 3. So we have negative 30. And here I guess I can just factor out the x and have ln x minus 1. And then the negative 3 times c can be absorbed, and it just becomes another constant. And then the next thing we do, we raise everything to the power negative 1/3. And because this is the last step, this C2 becomes our constant. And that's the answer. Let's see if Newton is going to like it or not. I think this is the answer. Let's try. Awesome. So let's go to question number 7. Another separable differential equation. And we separate it, so we bring e to the 3y to the left, so we have e to the negative 3y dy, equals -1 over x squared dx. Then we integrate. On the left side we have -1/3 e to the -3y. On the right side we just have 1 over x plus c, and seems like we're going to be isolating y, so let's call it c1. Let's multiply everything by -3, so we have -3 over x minus 3c1, so this can become c2. Now we have -3y, assuming that what's on the right is positive, so it's going to be ln of -3 over x plus c2, and now we're going to divide everything by -3, so it's going to be -1/3 ln of -3 over x plus c2, and because we are almost done, we're just going to turn c2 back into just a constant of integration c. So the final answer is -1/3 ln minus 3 over x plus c. That progress bar doesn't move too fast, does it? Y prime is equal to 6xy plus 42x minus 4y minus 28. And this, the only way this can be separable if we can factor the expression on the right side. So let's go ahead and try. We're going to take out 6x from the first two terms, and we're going to take out -4 from the other two terms, and there you go. Looks like we can factor it. And now we see that it is separable, so we're going to separate it. And proceed with integration. On the left side we have ln of y plus 7. On the right side we have 3x squared minus 4x plus c. Let's call it c1. So absolute value of y plus 7 is equal to e to the power 3x squared minus 4x plus c1, but we can pull that out from the exponent like this. Then we just call this c2, and now we have y plus 7 is equal to plus or minus c2 e to the power 3x squared minus 4x. So plus minus c2 becomes c3. And finally, y can be found by subtracting 7 from both sides. And since this is the last line, I'm not going to write c3, I'll just call it c. And this is my final answer. All right, a very similar problem. 20xy plus 5x minus 4y minus 1. The only way we can separate it is if we factor the right hand side. So let's take out 5x. So we have 4y plus 1. And let's take out -1 here. So we have 4y plus 1. And now we can see how it's separable. 5x minus 1, 4y plus 1. Now we separate it. So on the left side we have 1 over 4y plus 1 dy. On the right side we have 5x minus 1 dx. We proceed with applying integral to both sides. Now on the left hand side we have 1/4 ln absolute value of 4y plus 1. It's a simple linear substitution. And on the right side, we have 5 halves x squared minus x plus c1. So ln of 4y plus 1 is equal to, let's multiply everything by 4. So we have 10x squared minus 4x plus 4c1, which we now will call c2. Now we exponentiate both sides, so we have absolute value of 4y plus 1 is equal to e to the power 10x squared minus 4x times e to the power c2, which we would call c3. Now we have 4y plus 1 equals plus minus c3 e to the power 10x squared minus 4x. Let me go up. We're going to call this c4. Now we have 4y plus 1 equals to, actually, we need to subtract 1. So we're going to have c4 e to the power 10x squared minus 4x minus 1. And the last step, we're going to divide everything by 4. So we have c4 over 4 e to the power 10x squared minus 4x minus 1/4. And this we can turn into c5. So the final answer will be c5, which we can now just call c. And this is the expression. Let's... Oh no. Accidentally solved the whole problem. Didn't have to. All they wanted us to do here was to just write the integrals without finding them. So went a little too far. This was question 9, so let's go to number 10. Here we're separating, so I'm going to start separating right away. So 5x, we have 3y plus 1 plus 8, 3y plus 1. So the equation becomes y prime equals to 5x plus 8, 3y plus 1. And then we separate the variables, so we get 1 over 3y plus 1 dy is equal to 5x plus 8 dx. And this is the setup, and we are not asked to actually solve it. So let's not solve it. Let's just write what it's asking us to write. And this is the answer. All right, making some progress. Let's go to number 11. Now we have initial value problems. So that means in addition to a differential equation, we're also given initial condition. And first step is always the same. We need to find the general solution. So in this case, it doesn't matter what the initial condition is. It doesn't affect how we find the general solution. This problem actually is not separable because there's no y variable, but it just makes it even easier, right? So we're going to we only have 1 dy on the left, and on the right side we have ln of 7x squared over 2x dx, and we integrate it. So on the left side we end up with y, and on the right side we actually need to do a substitution. So let's set it up as a substitution. Actually, I don't need to call it anything. So let's call it substitution. And let's call t to be ln of 7x squared. So that dt will be, it would be 1 over 7x squared times 14x dx, which is 2 over x dx. So that means dx will be x over 2 dt. And with this substitution, my integral now becomes the integral of ln of 7x squared, which is ln of t, divided by 2x. But instead of dx, I'm going to write x over 2 dt, and you can see how x's actually cancel, and we have 1/4 integral of ln t dt. And I think even earlier in this homework I did compute the integral of ln of t. It's going to be t ln t minus t and plus c, but instead of t I need to write my actually what t stands for. So it's going to be 1/4 ln of 7x squared times ln of 7x squared minus t, which is, I guess we can just take out t here, put -1 here, and then we don't need this external parentheses, so we can be a little efficient, right? So here I'm going to write ln of that and put parentheses here, but then I don't need this parentheses. And all of that is plus c. And remember, this was an initial value problem, so we need to compute y of 1. So plugging in 1, what do we get? We get 1/4 ln of 7 times ln of 7 minus 1 plus c and all that has to be equal to 0. This is pretty insane. Result here that we got. So c, according to this, must be equal to -1/4 ln of 7 times ln of 7 minus 1. Meaning that the original function would be equal to 1/4 ln of 7x squared times ln of 7x squared minus 1 plus c, but c is what we just found earlier, so it's -1/4 ln of 7 ln of 7. Not looking forward typing this in Newton, but it seems like that's the answer. maybe we can simplify it. I'm not going to try, so I'm just gonna try to type it and hope that's the right answer. Let's see. We have 1/4 ln of 7x squared times ln of 7x squared minus 1. And now it's the same exact thing, but instead of x squared, it's just 1. So ln of 7, ln of 7, and it looks weird, but it is what it is. Hopefully it's right. And it's not. So let's find the mistake. So what I'm going to do is I'm going to put it in Wolfram Alpha to see what Wolfram Alpha has to say about this. Notice how Wolfram Alpha did classify this as a first order linear differential equation, but it didn't call it separable. But let's see. It's actually like this. I'm not doing something right here. Let's figure out what am I not doing right. So it's gonna be t ln t minus 1. I'm going to check because I also made an assumption that I know the integral of ln t. So let's check that one. So it was correct. So this is correct. This is t equals ln of 7x squared, so it's 14x. That's fine, right? So dx. Okay, this is fine. This is fine. So this looks fine. Instead of t, we put 7x squared. That's also fine. How come their answer looks so simple? And where does the 8 come from? That's the question. So we have this. We plug in 1. Oh my god, I don't see it for some reason. 1/4. Should I just copy this answer? And then I'll figure out. Maybe I'm like typing it wrong. Let's just type the actual answer. Oh boy. So ln of x squared times ln of 49 x squared. Is this going to be the right answer? Well, this is bizarre because oh my god, what did I do wrong? Oh my god, this is a terrible mistake I've made. Let me explain, and if you've seen it and you've been screaming at me, I'm sorry. After we do the substitution, we don't have a ln of t over here. We just have t. So we don't have any of this craziness here. We have 1/2 of t squared. 1/2 of t squared plus c. And I'll just erase all of this. This was such a waste of time. So this is it, right? So this is our solution plus c. So we have 1/8 t squared. So it's going to be ln of 7x squared and plus c. So now we're going to plug in 0. So we're going to plug in 1. So we have 1/8 ln of 7 squared plus c equals to 0, meaning c is equal to negative 1/8 ln of 7 squared. And the final answer will be y of x is equal to 1/8 ln of 7x squared minus 1/8 ln of 7 squared. So I'm curious, where did Wolfram Alpha got its answer? 7x squared, is this right? 7x squared over 2x. Anyway, so according to Newton, this is the right answer. According to Wolfram Alpha, I'm curious if it can be simplified, but oh, it actually can be. So this is actually a pretty interesting observation. Let me show you. Just to redeem myself and Wolfram Alpha, let me show you how this can be simplified. We can take out 1/8, and we can use the difference of squares formula to write it as the difference multiplied by the sum. And each one of those can be simplified. We have ln of 7x squared minus ln of 7, so it's 7x squared over 7 times ln of 7x squared times 7. Those are the properties of logs, and this is the final answer. Which is what I entered, which is what Wolfram Alpha got, which is what I entered, but it didn't count. So I'm going to let Newton know that something is wrong, and then we'll continue to the next problem. All right, let's move on to the next question. This was question 11. Let's do question 12. We have an initial value problem. And it's a separable equation, so we're going to separate everything. So we have secant squared 5y dy on the left, 2 cosecant squared 2x dx on the right. Throw the integral in there. On the left side we have 1/5 tangent 5y. On the right side we have negative cotangent 2x plus c. Now, to find c, we're going to plug in pi over 4 for x and pi for y, because this is my x, this is my y, and I'm going to take advantage of the implicit form. So we have 5 pi equal to negative cotangent 2 times pi over 4 plus c. Tangent of 5 pi, I believe it's 0. Cotangent of pi over 2, it's cosine of pi over 2 over, so cosine of pi over 2, it's 0. So it looks like c is equal to 0. So that means the equation that we have now, we need to isolate y, so we're going to multiply everything by 5. And we're going to take arctan and the last step, we're going to divide everything by 5. And that would be the final answer. This was number 12. Number 13. Initial value problem. It's a similar problem, the one I got wrong earlier. So you can look up my previous attempt and follow that, but I was going to show you another way here. We have we have ln of 2x cubed, which can be written as ln of 2 plus 3 ln of x using the properties of logs. And now we can find y by just integrating the right-hand side. But the right-hand side will be better off if we split it into two integrals like this. And this 3 clearly cancels this 3. So we have two simple integrals, one of which will be ln of 2 over 3 times ln of x. And the other one, this is where we do the substitution. So it's just going to end up being ln well, 1/2 ln of x squared, right? Let's double check. So if we differentiate this, we're going to have 2 times 1/2 ln of x times derivative of ln x, which is 1 of x, right? This looks right. Now, this is the initial value problem, so we're going to plug in 1, and we're going to have ln of 2 over 3 times ln of 1, which is 0, plus 1/2 ln of 1, which is 0 squared, plus c, and all that is equal to 0 means that c is equal to 0. And that means the final answer is y is equal to ln of 2 over 3 times ln of x plus 1/2 ln of x squared. And let's type that. So we have ln of 2 over 3 times ln of x plus 1/2 ln of x squared. That's 13. Let's do 14, another one of this. So pick your favorite approach and do it. I think the second approach was easier for me, so I'm going to, well, since it's the third time doing it, I'm just going to skip a step here. So let's integrate the right-hand side. And let's simplify it. So we have ln of 8 plus 4 ln of x. That's my numerator. And we're going to divide everything by 4x dx. So my integral on the left is ln of 8 over 4 times ln of x. And my integral on the right, after we cancel 4, is just going to be 1/2 ln of x squared plus c. And at 1, it's equal to 0. And because this is 0, so that implies that c is equal to 0. So y of x is simply equal to ln of 8 over 4 times ln of x plus 1/2 ln of x squared. Number 15. We have y prime is equal to e to the power 4x minus 5y. Y of 0 equals ln of 4. And we're going to separate it by first using the properties of exponents, and then by multiplying both sides by e to the 5y. And then we can split that dy dx and apply the integral to both sides. On the left side we have 1/5 e to the power 5y. On the right side we have 1/4 e to the power 4x plus c. And we can find c now by throwing in x equals 0 and y equals ln 4. So on the right side we have 1/4 plus c. On the left side we have e to the power of 5 times ln 4. 5 can be brought inside here, and then e and ln cancel each other, so we have 4 to the power of 5 over 5. 4 to the power of 5 is 1024 over 5 minus 1/4 is equal to c. So c is not a pretty number. And let's just leave it like this for right now. Let's isolate y from here. We're going to have 1, let's multiply everything by 5. So we have e to the power of 5y equals 5/4 e to the power of 4x plus 5c. Now if we take a natural log, we're going to get 5y equals ln of 5/4 e to the power of 4x plus 5c. But 5c, if this is your c, then 5c will be equal to what? It will be 5 times that, so it's going to be 1024 minus 5/4. But then we have another division by 5, so we're going to divide it by 5 again. So we have 1/5 ln of 5/4 e to the 4x plus 1024 minus 5/4. That's the answer that I got. Let's see if that's the right answer. 1/5 ln of 5 over 4 e to the power of 4x plus 1024 minus 5 over 4. Let's see. It's just never-ending homework. 15, 16, another separable equation, which is initial value problem, and we separate the variables. Integrate, so we have y squared plus y 4 times, I guess it's better not to factor here. So we have 2x squared plus 4x plus c. To find c, we're going to use this x value and use this y value. So we have 2 squared plus 2 equals 2 times 8 squared plus 4 times 8 plus c, and we have 6, we have 128, we have 32, and we have 160, so negative 154 is c. So the final answer is y squared plus y equals 2x squared plus 4x minus 154. It's in implicit form, but I'm afraid that this cannot be written in explicit form easily. So let's just copy the answer here. 2x squared plus 4x minus 154. Got that right. I think it was number 17, right? So this was 16, and we're gonna do 17, and hopefully the last y prime is equal to 10x plus 3 times y minus 4. So we have 1 over y minus 4 dy equals 10x plus 3 dx. So we integrate, we have ln of y minus 4 is equal to 5x squared plus 3x plus c. This is initial value problem. So let's just throw 0 for x and y, 1 for y. So we have ln of 3 is equal to 0, 0. So it's c. And now that we know what c is, let's isolate y. So we're going to exponentiate both sides. Now, ln 3 can be brought down by using properties of exponents like this. So e to the power ln 3 actually is just 3 in the front. Now 3e is positive, so y minus 4 must be equal to some positive value. Well, technically it doesn't, so hold on. How do we justify that it's not equal to negative 3y? Let me think. So if we plug in x equals 0, this is going to be equal to negative 3. And then y will be equal to negative 1 then, right? So it's not going to satisfy the initial condition. So it has to be positive over here. And finally, y would be equal to 4 plus... actually, no, hold on. It has to be negative over here, right? So in order for initial condition to be satisfied, this has to be negative. So maybe we plugged it in too soon. So technically it's plus or minus, but we're going to pick negative because negative is what's going to make sure that the initial condition is satisfied. So final answer is 4 minus 3e to the power 5x squared plus 3x. And so you see we did plug in we did plug in too soon, right? So y minus 4, y is equal to 1, y minus 4 is actually negative 3 here, right? So we need to remember that this must be negative 3. So let's just move on. And we are done. If you have any questions about how to solve separable differential equations, please reach out.